Let me do the next problem with you guys. I won't take as long for this one. I'm going to go through it. Perhaps work it out yourself before you see this explanation. Let's get to it. So I'm asking you the same information here, but I'm giving you different values in the problem. So to recap, frequency of the dominant allele, that's the letter P. Frequency of the recessive allele, letter Q in Hardy-Weinberg. Frequency of the population homozygous dominant, that's P square. Frequency of population heterozygous, that's 2PQ. Frequency of population homozygous recessive, Q square. Percent population that will have phenotype purple kernels, it's still purple kernels and yellow kernels as far as being dominant recessive. That's going to be homozygous dominant plus heterozygous for purple, just homozygous recessive for yellow. Same information, different values. Let me go ahead and get to it. Purple kernels, Y. Yellow kernels, lowercase, that is recessive. Random sample, 100. Taken from a population Hardy-Weinberg, it is found that 9 kernels display the homozygous recessive genotype. I'm giving you genotypes now. I'm not giving you the allele. I'm going to write more information here. So let me go ahead and write homozygous dominant, heterozygous, homozygous recessive. It is found that 9 kernels display homozygous recessive. That's 9 kernels. I'm going to go ahead and already say that's 9% since it's a population out of 100, and that's homozygous recessive. And it looks like 49 kernels display homozygous dominant. Ooh, more information. So 49 kernels, that's 49%. Okay, let me go ahead and use Hardy-Weinberg to answer these questions. I'm actually going to do the opposite, and I'm going to start with the genotype frequency equation first. P squared plus 2PQ plus Q squared equals 1. Okay, I already have P squared. This is P squared telling me homozygous dominant. 49% converted to decimal, 0.49. That is P squared. Always substitute homozygous dominant for P squared. I don't need to figure anything out. That is P squared. I don't need to solve for P yet. So that is homozygous dominant. I want to leave that as is. Homozygous recessive, I don't have that information yet. That's 2 times P times Q. Don't know that. Q squared, I do have that. That is 9%. That is homozygous recessive. I'll go ahead and write that this is heterozygous, and I don't know it yet. So homozygous recessive, 9%, divide that by 100, that is 0.09. I want to point out what a lot of students do is they'll be like, okay, 9%, they're working through this quick, so that's 0.9, boom, done. That's incorrect. A lot of students do that. 0.9 is saying 90%, but 0.9 is not 9%. Don't forget to add that extra 0. That'd be 0.09. Okay. Looking at all this information, I can use algebra to find my heterozygous information. That is 2PQ. Before I do that, I actually want to go ahead and fill in what I do know already. I know homozygous dominant, that's P squared. Let's go ahead and fill in that bullet point. That's the frequency right there. I also have homozygous recessive, that's Q squared, 0.09. Boom, got those down. Let me find heterozygous. Oops. Okay. Heterozygous 0.42 frequency. I can answer bullet point 4. There are my genotype frequencies. I can actually already answer, so I don't really have to go in order here. It depends what information that the problem gives me to answer these Hardy-Weinberg frequencies and percents. I'm actually already going to go on to bullet point 6 and 7. I want to find the percent of phenotypes. I'm going to go ahead and add my let's go ahead and put that this is at 42%. Okay, I'm going to go ahead and add my homozygous dominant plus my heterozygous, that's 49 plus 42% to give me my purple kernel phenotypes, and that will be 91%. To answer the next one, that's just simply going to be the homozygous recessive, 9%. Do they both equal 100? They do. My work checks out. We can also check this out. Does 0.49 plus 0.42 plus 0.09 equal to 1? They do. I need my allele frequencies. I still haven't found P by itself. I still haven't found Q by itself. Don't forget bullet points 1 and 2. So I'm going to go ahead and figure that out now. I'm going to use my information from the genotype frequency equations to figure that out. If P squared equals 0.49, then I can figure out P by squaring both sides. P then is going to equal 0.7. That's how frequent the dominant allele is in that population. Before I continue, we just kind of think about the concept behind that. That's a high frequency. About 70% of individuals will have the dominant allele. That makes sense because my homozygous dominant was quite high in that population. The frequency of my heterozygous was also high. That does equate. There are a couple ways you can solve for the next allele. I'm going to go ahead and use the Hardy-Weinberg allele equation to do that. That's P plus Q equals 1. I have P, that's 0.7. We just figured that out. I don't have Q yet. I'm trying to solve for that. I set that equal to 1. 1 minus 0.7 will give you Q. That is, I'll write it over here, Q is 0.3. Final answer. I hope this explanation has helped you guys out, and contact me with any questions you may have.